My dear students, today we will discuss few more concepts related to solution of differential equations. We know that that is to find the solution of the any differential equation. There are two components. The solution of differential equation has two components, that is natural response and forced response. The combination of some of these two, that is here is there, the complete response is nothing but the it is equal to sum of the natural response and forced response. That is, when we combine the natural response and forced response, then it is called as complete response of a differential equation. In the previous video lecture, we have discussed about with an example how we can solve, we'll find out the natural response of a differential equation. Today we'll discuss about, in this video lecture, we'll discuss about how we'll find out the forced response. While finding the forced response, here we'll consider the initial conditions as zero. Here, this is the output produced by system only due to input. We'll consider input, but initial conditions are considered zero for forced response. It is what that is. It is denoted by y raised to f of t. That is, f stands for force response. Here y raised to n, here where here y raised to n stands for, it is natural response. N for natural, f for forced response. Now with an example, we'll discuss about how we'll find out the forced response. That is, the forced response y of t equal to the forced response of system is obtained only for input with zero initial conditions. The forced response, this forced response is also consists of two components. That is, to find out force components, we have to find out two components. That is, first one is the term similar to natural response. Second one is particular solution. Here this is the combination of the term similar to natural response. One more term which is there in the force response is a particular solution. A particular solution is denoted by y of p. That is, particle p stands for particular solution. Y of p t, it has the same form of the input. In table 3.21, this table 3.21 shows the typical input and equivalent forms of particular solutions. In the notes also, I have drawn this table. That is, this table representation represents the forms of a particular solution. If input is like 1, some constant, the particular solution will be k. If input will be is of form e raised to minus 80, then the particular solution will be k into e raised to minus 80. Like this, they have given for various input, then what are the particular solution. You refer the table to find out the particular solution. With an example, we will discuss and we will come to know what is a natural response, a term similar to natural response, and a particular solution, so that we can find out the force response. Here with an example we discuss. Determine the force response of the system. They are given a differential equation. From that equation, we will find out the force response of the system. That is, differential equation is phi dy raised to t dt plus 10 y raised to t equal to 2x of t. For the input, x of t equal to 2 u of t. Here, this is the equation they have given. They have given the differential equation, and we have to find out it is a force response. We have to find what's its force response. The force, already as I told that the force response consists of two components. That is, one similar to natural response plus this particular solution. First, we will find out what's its natural response. Here, to first step to determine what is y of n. First step is what? To already we discussed how we'll find out the natural response. Same steps are followed to obtain the roots of a characteristic equation for the order n. Here, since what type of differential equation this is first order differential equation. Therefore, for the order n equal to 1, therefore we'll consider the value of n as 1. Therefore, the equation to find the roots of a characteristic equation, we have the equation already in the previous class. We have discussed about how we'll find out the roots of a characteristic equation. This is the equation to how we can calculate the roots of a characteristic equation. That is summation equal to k equal to 0 to 1. Why? This is first order equation, differential equation. Therefore, we will consider only one. That is ak r raised to k equal to 0. Then you elaborate this equation. Then it will be it is equal to substitute the value of k as 0. When we substitute the value of k as 0 in this equation, this is equal to a0. If r raised to 0, r raised to 0, what is the value of r raised to 0? It is 1. Therefore, we will get what? a0. When we substitute the value of k is equal to 0. Next value, summation means, if suppose summation 0 to 10 means addition all sum of all the 10 numbers. But since here only 0 to 1, we have to consider substitute the value of k only. Here it is 0 and 1. If it is 0 to 10, then for different we have to do the summation of all this. A raised to 1, a raised to 1, a raised to 0, a raised to 1, a raised to 2, a raised to 3, a raised to 4, like this. But here only it is summation from 0 to 1, we will get only 2 terms, that is a raised to 0. And when we place the k equal to 1, therefore a1, here r raised to 1. R raised to 1 is nothing but r1 only. This is r1 and this is k equal to 1, a1 r1. It is equal to 0. That is, from this equation we will get this term, this equation. In this equation, here compare this equation from equation 3.2.11. This is 3.2.11. Here this equation, these are the things but the constants of these differential equations. This is what? This is your a0. This is your a1. Therefore, comparing those equations, that is a0 equal to, here this is a0, this is your a1. Therefore, substitute those values in this equation. Then 10 plus 5, 10 a0 a1, a0 10, a1 5. Therefore, 10 plus 5 r1 equal to 0. Therefore, we will find out the value of r1 as that is, take this 10, take this side, then it becomes minus 10, and divided by 5 will get minus 2. R1 equal to minus 2. We will get the R1 value as minus 2. Then second step is what? To obtain form of natural response. The natural response, that is, we know that the equation to find out the solution of a natural response, the equation is y raised to n t equal to C1 into e raised to R1t, R1t, C1 into R1t. Here already we got value of R1. R1 is what? Minus 2. Substitute that value in this equation we'll get C1 equal to e raised to minus 2t. R1 is minus 2. Substitute in this equation, then it will be minus C1 e raised to minus 2t. Now, but we have to find out, okay, next afterwards we will find out the value, what is the value of C1, and after first we will find out what is our particular solution to determine y of p. Y of p is what? There is nothing but particular solution. Already we told that the force response contains a term similar to natural response and particular solution. In particular solution, form of particular solution, the particular solution is of the same form of input. Here x of t is 2 of ut. That is constant. It is like some constant. When some constant is there, hence from table 3.2.1, the particular solution will be of the form y raised to p raised to t equal to k. If some constant is there, from forms of particular, if some constant is there here like 1, then the particular solution will be k. Therefore, some constant is, this is what? 2 raised to u of t is some constant. Why? 2 x of t equal to 2 into your u of t. What is u of t? U of t is nothing but a unit step function. Unit step function which is having the amplitude 1. Therefore 2 into 1 is 2. That is nothing but some constant. It is constant value. Therefore already we know u of t, u of signal. Different, while discussing about the different types of signal, we have discussed about what is u of t, what is delta t. So many things we have discussed. That u of t is a unit step response, unit step signal, unit step function with amplitude equal to 1. Then 2 into 1 is 2. Therefore it is a constant. Then here some constant is there. Then what is its particular solution? It is k. Therefore the particular solution we got is k. Then what we'll do? We'll find out the values. To obtain the values of constants in y of p t k, we have determined the value of k for which y of p t satisfy the system. Now we'll find out the value of k here in differential. Hence putting y of, now we'll find out what is k, what is the value of k. Then for that, hence putting y of t equal to y of p t equal to k and x of t equal to x of t equal to 2 of ut in equation 3.2.11. Where is equation 3.2.11? Here, this is the equation. This one 3.2. This, in this equation, this is the equation what they were given, where we are, in which equation for differential equation we want to find out the forced response. In this, what we'll do, we substitute what the wherever y of t is there, that we will consider as y of pt equal to k. Means here wherever y of dy that is y of t is there, there we will substitute the value of k. Then we'll get the values. We can find out the value of k. Therefore this equation becomes 5, that is 5 d by dt. In place of yt we will place what is k, plus 10 here. This what yt what we will place the value of k. Then this is equal to 2 into 2 of here 2 x of t. 2x of t. What is x of t? X of t, here 2x of t is there, but here what is the value of x of t? X of t is nothing but 2 u of t. Then in place of, if place the value of x of t in this equation, then it will be 2 into 2 u of t. U of t, we know what is the value of u of t, that is 1. Then it means this is nothing but 2 into 2. 2 into 2, that is 2 into 2 of ut. Ut is nothing but 1. Therefore 2 into 2, that will be equal to 4. But here you see here y of d raised to by dt k equal, but here here this term becomes 0. Why? Because here we are differentiating with respect to dt, but the term is k here. Therefore, suppose here you see this one here, then if you are differentiate dt with y of t, will get some value. But since here also yt is there, dt is there. But here in this equation, we are differentiating with respect to t, k with respect to t, then it will consider as a constant. The differentiation of any constant, it will be 0. Therefore differentiation of a constant is what? 0 only. Therefore 0 plus 10k as it is equal to 4. 2 into 4. Therefore then k equal 10k equal to 4. Therefore k equal to 4 divided by 10, that will be equal to 0.4. This is how we have found out the value of k. Then this substitute the value of k in the particular solution. Then the particular solution will be in the form that is y of pt equal to 0.4. Why? Because y of pt equal to, it was y of pt is equal to k. Therefore, we have found out what is the value of the k. Therefore, the value of k is 0.4. Next, we have to find one more c1. I think we have to find out c1 to determine y of t. Y of t equal to y of raised to n natural response plus particular response. Therefore, it will be c. Already we have found out what is the value of y and t. That is nothing but c1 e raised to minus 2t plus 0.4. But obtain the constant in y of t with zero initial conditions. Now, still we have not find out what is the value of c1. Therefore, we have to find out the value of c1. Therefore, to find out that one, what we have to do, we'll consider the zero initial condition. Means y of 0. If you take this as y of 0 equal to 0, putting these values in the equation 3.2.16. Where is 3.2. This is your 3.2.16. In this equation, substitute the value of y of 0 as 0. That is zero initial conditions. Here, y of 0, 0 initial condition is equal to 0. Putting these values in equation, then this y of t equal to y of 0. Y of 0 is 0. Then here c1, here in place of t, substitute the value of t as 0. Then what happens? This term, complete term, becomes 0. Then e raised to 0 is what? 1. Therefore, we got 1 multiplied by c1 only. Therefore, we have c1 plus 0.4. Therefore, here we go out this equation when we consider the initial conditions, and that is y of 0 is equal to 0. Then 0 equal to c1 plus 0.4. Then what is the value of c1? Take that side, then that will be, when it comes to this side, then this will be minus 0.4. Therefore, the value of c1 is minus 0.4. Substitute in this equation. When we substitute in this equation, then that will get the force response as minus 0. Here minus 0.4 into e raised to minus 2t, e raised to minus 2t plus 0.4. Then what we'll do, we'll take this side and this side, and we'll here, since here also 0.4 is there, here also 0.4 is there, we'll take 0.4 common, and this will be 1 as it is. Since we have taken this side, this side, then we have taken 0.4 common, we are left with 1 here, 1 minus e raised to minus 2t. This is what the solution of a force response. That is what, this is the force response of a given system. This is what force response. How we have we will find out the force response. In first internal, in the question bank, we have given find out the natural response, the force response, the complete response of a differential equation. Complete response means nothing but, here complete response is nothing but that is nothing but at that time you have to find out the natural response, force response. Combination of that, the complete response is equal to sum of natural response and force response. Then if suppose they will give such equations, you have to find natural response and force response, then add that one, sum of that one is nothing but the complete response. Here the complete response is equal to sum of natural response and force response. For this, both the input and initial conditions are considered. Here for complete response, you have to consider the input also as well as initial conditions also. In next video lecture, I will discuss about this. How we'll find out the complete response of this differential equation. Okay, such problems will be asked in exam. you refer the question bank. For some, there the problem may be different, but the pressure of solution is same for all the problems. Okay, okay. Thank you.